Dear students, here welcome to Dr. B.R. Ambedkar Open University video classes UV Computer Applications Semester 3. Program is CNC++ Unit 5 Functions Part 2. Already here Part 1 were completed. In this video, I am going to continue the Part 2 here Functions chapter. In Part 1, we are learned about here what is meant by function, why it is required function, what is the need of the function, what are the advantages of functions, and next here syntax of a function, examples of a function, how to write the programs using the functions. Is all we are learned in a here previous here part 1. Now in this part 2 we are going to continue with the functions, unit 2 functions. Here parameter passing we are going to learn in this. And next what are the preprocessor directives are there in functions, we are going to learn. Next, recursive functions, what is meant by recursive function, here how we can use the recursive functions, what are the benefits of recursive functions, what is meant by preprocessor directives, here preprocessor benefits, how many types of preprocessors are there. These all kind of things we are going to discuss in this here second part. See here, don't skip the video. Here you can listen here carefully. First, we are going to learn about types of parameter passing in C. In functions, parameters, that means arguments. Arguments passing in C are two types are there. First type is called as a pass by value, that is call by value. Second one is pass by reference, that is call by reference using pointers. So call by value, call by reference. What do you mean by call by value? What do you mean by call by reference? In detail, with the example program, I will explain in detail in simple English. See here, pass by value. What do you mean by pass by value? See here definition first. What do you mean by pass by value means a copy of the actual value is passed to the function. Any changes made inside the functions do not affect the original variable. That is called pass by value. Here, any changes made in the inside of a function, it is not affected to original value. And that is called as a here pass by value. See here in this example program, here we have a two functions. One is called main function. Another one is called as a subprogram or subfunction is there. In the main function, we have a one variable. What is that variable? Here x is a one variable. What is the type? Integer type. What is the value? Value is 20. So in main function, variable is x, but value is 20. That is called as actual value. Actual value is 20. Then we are called here function. What is that function? Display. Display function. I told you in part 1. What is the syntax of function? How many parts are there in function? I told you. Again, I will tell you a little bit here briefly. Here in a function, what is the function name here? Display is the function name. Void is the return type. Int num is the parameters. What is the local variable? Here a local variable is here in local variable we are not declared here. Directly we are assign the value number equal to number plus 10. So no return statement. Return statement is optional. So this is all about a function, display function. Here in display function, we are assign the value number equal to number plus 10. Number plus 10. Number is 20. We are passed the value, actual value 20. That is passed to this subprogram. Now 20 plus 10, 30. So that's why inside of a function, value is 30. 20 plus 10, 30 came. But here in a main function, what is the value inside of a main function? Value is here 20 only. So 20 is not changed. That's why pass by value, call by value means actual value is passed to the function. Any changes made inside the function do not affect the original variable. Original variable. In inside of a function, we are change the value. Number equal to number plus 10. Inside of function, we are changed. But it is not affected to main function. That is called as a call by value. See here, pass by value. I think it is clear. Simply one line. Here, whatever changes we did in inside of a function value, that is not affected to main function, that is called fall by value, first category. In this second category, what is the second category? See here, in the second category is pass by reference. What is meant by pass by reference? Reference. See here, pass by reference. Reference means here using pointers we can do this. That is here address of the variable is called as a pointer. See here, pass by reference means the address of the variable is passed to function using pointers. The function can directly modify the original variable. So here in previous one, original value is not changed. Here only inside of a function value is changed. But now here inside of a here main function value, directly we are doing the modification. Original variable can be directly modified. That is called as a pass by reference, call by reference. How we are changed means using the pointers. Here we have to know about pointers. Without knowing about pointers, we can't get a clear picture about pass by reference or pass by call by reference. So we are passing the pointer. So what is meant by pointer means address of the variable. Address of the variable is called as a pass by, that is pointer. So here in this same two functions are there. One is called main function in here right hand side. In left hand side, that is function is there. That is called as a user defined function. In here that is subprogram. In this subprogram name, what is the name? Display. What is the type? Void. What is the pointer variable? Int star number. Generally, we are declare or we are declare the pointer variables. How means integer star here variable name. So that's why parameter we are passing that integer star number. So now here in main function, come to main function. In a main function, variable value x equal to 20, that is address of value we are displaying, then we are printing. So here value star number equal to number plus 10. So number plus 10 means automatically already number is passed to here subprogram. So subprogram value can be changed. 20 plus 10, that is 30k. So that's why this is called as a pass by reference. Reference means address we are passing, then if we are affecting the or we are changing the or modifying the original variable value. Where it is original variable value? That original variable value is there in a main function. Here I told you, your right hand side, that is called as a here that is main function. Left hand side, that is called a subprogram function, subprogrammer function. Here in a main program, that is value is their original value. That value is here x, value of the x is 20. So that value can be changed. So that's why output value is x equal to 20. See what I'm telling to you here, passing the parameters two ways are there. First one is pass by value. Second one is pass by reference. Pass by value we are passing here in previous one. Now here what we are passing? Address we are passing. That's why display of present x. So x address we are passing. So this is called as a pass by reference. Next we are going to uh, learn about difference between pass by value and pass by references. So here in this one, so many differences are there. Where I identified here mainly five differences. One is pass by value, pass by reference. So very simple now. So here one is pass by value. First one, copy of the value is passed. So whatever value we are passing, that is copy of the value is passed. In this pass by reference means, call by reference means address of the value is passed. So value is passed here, address is passed here. This is the first difference. Here new value is passing, here address is passing. That is the first difference. Second one is in pass by value, original value is not changed. Here in pass by reference, original value is changed. I told you, here x value 20 not changed in pass by value, but in pass by reference, x value 20 is changed. That is the second difference. Original value is not changed, original value is changed. In third one, here uses normal variables. Here uses pointers. X is a normal variable. Why? In previous example, clearly I told to you, x is a normal variable. That is integer x. Here integer, here x only, but pointer address we are taking. Ampersand of x we are passed. So pass by reference we are using the pointers. Pass by value we are using the variables. So it is pass by value is safe and simple. Safe and simple. Why it is safe and simple? Here simply we are passing the value. Pass by reference is faster for large data. Why? Because so here only address, for example, we know in address only house number means here it is difficult. But address with house number, with location, with all we know means we can find out particular person very easily. So that's why it is faster for large data. Next, last one is extra memory for copying. So in this one value it will take the extra memory. But in reference, whatever address is there, that address we are passing, extra memory we are not using. That's why here memory is no extra memory is created for pass by reference. Whatever address is assigned for variable, that address only we are passing. But in pass by value, here extra memory is for copying. So these are the basic differences between pass by value and pass by reference. So here I think it is clear. So here what we discussed first topic, here pass by value, pass by reference. Next, what are the differences between pass by value and pass by reference? Now we are going to learn about second topic. What is the first topic? I told you, what is the first topic? Here types of parameter passing. Secondly, we are going to learn about recursive function. What is meant by a recursive function? See here, what is meant by recursive function? A recursive function that calls itself to solve a problem by breaking it to smaller sub-problems. A function calling itself to solve a problem. A function calling itself to solve a problem. Here and next, how we can solve? By breaking into smaller sub-problems wise, we are dividing. And that's why that is called as a recursive function. Every recursive function has two essential parts are there. What are the two essential parts? First part is called as a base case. Second part is called as a recursive case. What do you mean by base case? See here, base case means the condition that stop the recursion. That is called as a base case. Whatever condition is there, that condition automatic condition is stopping the recursion procedure. That is base case. Second one is what? Recursive case. See here, the part where function call itself within a smaller or simpler input. Here the value can be decreased like first 5, next 4, next 3, next suppose 5 factorial we can take. Here first 5 into 4 into 3 into here 2 into 1, like this smaller part. That's why I wrote here recursive case means the part where the function calls itself with a smaller or simpler input, with a smaller or simpler input, that is called as a recursive case. Here example 1, see here the factorial number, we can best example of recursive function. Very simple, within one line we can remember a function calling itself by solving the problem and divide into smaller sub problems, that is called as a recursive functions. Okay, so example 1 factorial we can take 0 factorial, we know very well 1. N factorial means n into n minus 1 factorial. I told you, 5 factorial equal to 5 into 5 minus 1, that is 4. Again 5 minus 1, 4 factorial. 5 into 4 factorial means 4 minus 1, that is 5 into 4 into 3 factorial. Again 5 into 4 into here 3 minus 1, 2 factorial, that is 5 into 4 into 3 into here 2 factorial. Like this, here up to smaller number it is displayed. That is called as a here recursive function. Best example is factorial of a number we can find. See whatever I had explained again. See here factorial of 5. First 5. Next factorial of 4. Next factorial of 4. That is 5 into 4 into factorial of 3. Next one is here 5 into 4 into 3 into factorial of 2. Next one is 5 into 4 into 3 into 2 into factorial of 1. Next one 5 into 4 into 3 into 2 into 1 factorial of 0. I told you, factorial of 0 means 1 only. That's why 5 into 4 into 3 into 2 into 1 into 1. That's why it is 120. Like this we can calculate using the recursion. So very easy to n into n minus 1 we can use. So here again what is the difference? So don't confuse about here recursion and iteration. Both are not same. Here recursion is different, iteration is different. So don't confuse. That's why I'm giving to you again what is meant by recursion, what is meant by iteration. So I identified four differences. So here one is what is meant by recursion, what is meant by iteration. Clearly we have to identify each and every one in detail. Here difference. First one is a function calls itself. So iterating, where we are using iterating. Here iterating, what is the meaning of iterating means repeating. Here repeating, where it will come repeating word. In a loops we can use repeating word. Same type we can repeat. Same total we can repeat. Up to the condition is false. We know in already conditional here statements in C. Conditional statements, looping statements, and conditional statements, like this decision making statements. These all we know here. In loops we are using the iteration. Here looping statements we know very well in C language. What are the looping statements here? For, while, and do while. So I mentioned here only two types of loops. So iteration uses the loops. Recursion, a function is calling itself. Second one is it is required the base case. So base case is, I told you, in base case means what I said here. In base case means the condition that stop the recursion. So base case means condition can be stop the recursion. That is called as a recursion. In this iteration requires loop termination condition. If you want to stop the iteration, here terminating condition it will come. That is until condition becomes false. Until condition becomes false. So condition becomes false means automatically iteration can be stopped. So here base base case is used to stopping the recursion. So recursive problems can be solved in purpose. We can use recursion. So here iteration. Here in iteration, memory can be efficiently. That means same type printing 1 to 10 numbers. Here squares of 1 to 100 numbers, cubes of 1 to 100 numbers. Like this, we want to find out means easily it is possible with the help of iterations. So next one is here fourth one, last one. Here uses the call stack. Here call stack it is maintained. Here it is used here constant memory in many cases. Stack it is used. Here it is used the constant memory. So these are the basic main differences between here recursion and iterations. Basic difference between the recursion and iterations. So I think it's clear. So what we learned, second topic, recursive functions. What do you mean by recursion function? Here how we can use. So here in the recursion, here we can learn in detail. Then next third topic, here what is the third topic is here preprocessor directives in C language. What are the preprocessor directives? What is meant by preprocessor directives? So preprocessor directives means what? How many types are there? Like this we can learn. Preprocessor directives means special instructions that are processed by say preprocessor before program is compiled. Generally, every program we want to get a result means what is required. Every program we want to here uh, here we want to get the result means first we have to do the compiling. Then we are going to here executing. Here compiling, here earnings, errors it is displayed. Then we can identify that earnings. Then we can identify that here warnings. Then here identified, then we can correct. Then only we can get the output. So before getting compiling, preprocessor directives are giving the instructions. Here giving the instructions. They tell the compiler here what type of instructions it will give means they tell the compiler how to prepare the source code for compilation. How to prepare source code for compilation. This kind of instruction is given by preprocessor directives. So mainly in preprocessor directives, three things we have to remember. First thing is every preprocessor directive is starts with the hash symbol. Every preprocessor error directive is starts with the hash symbol. Second one is here it is not end with the semicolon. They do not end with the semicolon. In generally we can say that every in C language every statement is ending with the semicolon. But here in preprocessor case what we can say they do not end with the semicolon. That is the second rule of preprocessor directive. And third rule here, they are executed before the actual compilation of the program. Before compilation of the program only, preprocessor directives are executed. These are the things first we have to remember about the preprocessor directives. What are the things? What do you mean by preprocessor? In preprocessor means it is giving the instruction to compiler. It is giving the instruction to compiler. Here, here, what kind of instructions? Here, compiling of source code. Tell the compiler how to prepare the source code for a compilation. So the three rules are followed. Simple now, very simple. First one, here hash symbol is there, semicolon are there, and next one is here before only it is executed. Simple. Hash not semicolon here next execution before only. These are the things we have to remember in this preprocessor directives. Next we are going to discuss about preprocessor directives syntax. How to here declare how to use in C program. First, we have to know the syntax. What is the syntax here? Syntax means in directive name with the arguments we can specify. This is the syntax. So, for example, we want to give the preprocessor pi value. Here we want to give means here you can write like this hash include stdio.h, that is header file. We can mention the header file, then we can go for hash define here pi 3.5 value, that is 3.14. So here preprocessor, constant preprocessor we are mentioned here, constant preprocessor we are mentioned here. I will tell you now here what type of preprocessor directives are there. This is syntax. What is the syntax? Hash is common. I told you, first one, hash symbol is there, no semicolon. No semicolon is there. End with not end with semicolon. Start with here hash symbol. These are the main two important points we have to remember whenever we are using the preprocessor directives. First one is before, beginning hash is there, ending no semicolon. Here these two things we can remember always in whenever you are using the directives, preprocessor directives. Beginning hash is there, ending no semicolon. Here next, this is very easy, syntax, no need to by heart here. So here, what are the advantages of preprocessor directives? So here so many advantages are there. I mentioned here only 5 types of advantages. Why here whenever we are using the preprocessor directives, what kind of advantages are there? The first type of advantage is here makes a program easy to understand. Make a program easy to understand. See here in previous one, constant pi value. We know very well pi is constant value. So constant value means once where that is fixed, not changed. 3.14. Here 22 by 7. We can understand easily what kind of value we are used, constant value. So it is fixed entire program execution where that value is cannot be changed. So that is you preprocess, using preprocess we can understand the program very easily. Next one is improve the code readability. Improves the code readability. That means here we can easily read in just within one line as defined pi 3.14. Readability code we can improve. That is available for with the help of a preprocessor. Improves the code readability. And third one is makes maintenance easier. We can maintain the here preprocessor directives very easy. It is not complex. Here complexity not there. Makes maintaining the here maintaining the yeah maintaining the uh, preprocessor directory is very easy. Next one is supports conditional compilations. I will tell you conditional compiling directives. Conditional directives I will tell you. Conditional compilation. Conditions are there. Compilations. So that is also supported by preprocessor directives. Supporting conditional. Yeah, condition is there. Conditional compilation is supported. And last one here helps in creating reusable code. Yeah, reusable. Creating reusable. Re means I told you already. Re means once again we can use. Here once again we can use the code. Creating the reusable code. Name only explanation. I think no need to worry about this. Simple, very simple now. Helps in creating reusable code. Once again this code can be used. So whatever code we wrote with the help of a preprocessor directives, the same code we can use. One more thing also we can learn about preprocessor directives. Here every instruction with the help of a preprocessor within a short within a short line we can write here. Larger line no need, I think so. So shortly we can mention, so easily remember, easy to understand, easily read, easily maintain, easily. Next, conditional compilation and reusable code also provided. These all are the here advantages. These all are the benefits of a here preprocessor directives. And next, we are moving to disadvantages. So we know very well advantages are there means disadvantages compulsory. So everything, every component, everything, some advantage benefits are there means automatically there is disadvantage also there. Every element, I think so. Advantage some, just you can take human. Here some good characteristics are there. Automatically we can another side. Here in one side, here head is there. Automatically tail also there. So head is there, tail not there means that is like. So here advantages are there, same time disadvantages also there in a preprocessor directives. So here what is the first disadvantage of preprocessor directives? The first disadvantage is here macros can make code difficult to debug. So one here directives means okay, two directives, okay. So too many directives are there, too many preprocessor directives are mentioned, are another name macros are mentioned means it is debugging. That is here whatever whenever error came, we want to find out that error, it is difficult to debug. Too many macros are there, too many here, too many preprocessor directives are there means a difficult debugging is difficult. Second one is macro expansion by may increase program size. So you can expanded means automatically we know that expanded automatically increase the size. Where expanded means it is increase the size. So macros here increase the size. Next one here identifying the errors. Errors in macros are sometimes difficult to identify. So errors are there. In this errors, whenever arised in macros, here we want to identify that macros errors means it is difficult. So these are the three very easy, no? Here first one is what? Here difficult to debug. Too many are there means difficult to debug. Next, expanded means it is occupied more space. Next one is here. Next one is here. Uh, yeah, errors are there means identifying is it is difficult. These are the three disadvantages of a preprocessor directives. And next one is yeah. What is the next one? What we learn? Still now we are learned about here what is meant by preprocessors. What is meant by preprocessors? Here next one is preprocessor directives, and next one is advantage of preprocessors, disadvantages. Next one, what are the common preprocessor directives? So commonly used preprocessor directives are three mainly. So many are there. I'll tell you here. Only I'll tell you mainly. So here commonly used preprocessor directives are three we are using in a C language programming. Here first one is hash include. In a hash include is here used to include header files in a program. Header files can be including purpose. We are using this include hash include. Generally, input function, output function. I told you, input function, output function. We want to here access means what we required here hash include stdio dot h standard input output scanf printf. Input is scanf function, output is printf function. So you want to access means so hash include a compulsory. So makes library functions available. Here hash include stdio.h. Here why we are using this? In a library functions we want to access means this directive can use. This is the first directive, hash include directive. Okay. Second category of directive is hash define. See here, hash define is defining the constants or defining the macros. Constant, maybe a constant value we can take. Fundamental constant value is pi value. Pi is 22 by 7 or 3.14. We are defining the pi value. See here in this one pi value, here 3.14. We are not only here pi value, we can take one variable variable and also we can fix it with some constant value. As defined pi 3.14, has defined x some 5. We can write x value 5, fixed constant. We want to mention else. We want to define means we can use this second type of directive. This is second type of directive, second category. Third type of directive is hash undefined. Hash undefined. Why we are using this? Use it to remove the previously defined macro. Why we are using undefined means removing of previously defined macro. For example, we are here defining the size value. What the size value is here? Hash defined size is 100. We are defined hash defined size is 100. We are defined. So we want to here remove this size 100 means we can take here hash and def size, and def size means automatically it is removed. So mainly here I will tell you later on, so many are there preprocessor directives, but mainly here three types of directives you can remember. One is hash include, second one is hash define, and third one is undef. Third one is undef. Hash include here makes library functions available purpose. As defined, defining the constant value. Hash undef means removing the defined macros. Very easy, no? So these are the three common preprocessor directives. So many here in example program we can take using the preprocessor directives. What is the example program here? What is the example program here? In this one, first line, we know very well. Hash include stdio.h. Header file, standard input output header file, we are declared. Next, we are taking the define preprocessor directive. Define. What we are defined? Pi value we are defined. Pi equal to 3.1. Pi value we are assigned 3.14. Next, we are taking the radius value, float, category or data type, not category, data type, float. Yeah, float means we know very well. Decimal values we want to process means we can use this is float. So radius 5. Here float area equal area. Float area, float radius value 5. Now we are calculating the area. Here pi into r square. Pi r square. The area of circle. We know very well about area of circle. What is the formula? Pi r square. Here area of circle pi r square. Perimeter of circle 2 pi r. So we are finding here area of circle. So we are passing the radius pi. Pi value are passed. Then we are calculating area of circle. Then we are printing the area of circle. So what is the main intensity here? What is the example for why I wrote here? This is the preprocessor. Preprocessor directive. What type of preprocessor directives here we are used? Two are there here. Hash include is there. Hash define also there. Common in out of common three preprocessor directives, two I used. Here understood I think so. One first one is hash include. Second one is hash define. define the constant value. So this is the example program of preprocessor directives. Next, last one. Here, thank you so much for patiently you are listening my video. So here, in this one, conditional compilation directives. I told you, here advantages. Conditional compilation is supported. One of the advantage I told you, conditional compilation is supported by preprocessor directives. So here, these directives all are compile the code only when the certain conditions are true. So conditions are true means these all will be compiled. So these are categorized into 6 categories are there. Here one by one I'll tell you. Here in first 2 or 3 I'll tell you in detail. In here definitions, I'll give you in previous next. Just I'll give you the meaning with example. I'll explain to you. See here, how many are there? Conditional compilation directives. 6 are there. Hash if def, hash if and def, hash else, hash else if, hash and if. So these all are the here conditional compilation directives. 6 types are there. First one we'll see here, hash if. Already we are learned in I think decision making statements in C. Already we are learned, but here again see here hash if. What do you mean by hash if? Here hash if directive compiles the code only if the given condition is true. I told you, conditional compilation. Conditional based only compilation will be done. That is called as a compilation. Conditional compilation. Here in this one, hash directive is there here. Hash if directive is there. If means already what we have learned. If condition is true, then statements are executed. Here same like this. If condition is true, then it will go for compiles. That is, directive compiles the code only given condition is true. See here syntax. This is the definition first I gave to you. What is the definition? If directive compiles the code only if given condition is true. If true only means then only it will do the compiles. So syntax. This is the definition. Now we can go for syntax. What is the syntax? If condition, if condition code is there and if is there. Out of 6, we are used the 2 we are using here. One is if and if is there. If is ended, that is and if. So here that is the syntax. Now I'm taking the value here. Value is 10 into main. If value greater than 5, print value is greater than 5 and if return 0. So here value is greater than 5. That means what is the value actually? In a value is simple, no? Defined. Value we are defined. Constant value are fixed. I told you x is some value fixed. But here we are fixed that value is fixed. Value variable is fixed. What is that value? 10. 10 is greater than 5. Condition true only. 10 is greater than 5. Condition true. So that's why it is true. It is executed. That is value is greater than 5. Output it is came. This is the first type of if directives. Next, I think understood if directives. What is my if directive? Conditional based compiling. If condition is true, then compilation will be done. What is the condition base heart of this here program? Value greater than 5. This is the key, I think so. Key step is value greater than 5. Here value is actually 10. That is greater than 5. So automatically it is printed. Output is greater than 5. Second type of your directives is if def directives. That means if defined, if def is there, if def, not def, defined here, if defined. If defined means where checks whether macro has been defined using the define. Here defined, naval explanation. If it is defined or not, it will check. If it is defined or not, it is checked. That is called as a if def directives. How we can define if def? That is macro name. Then they can write the code. Then we can write the end if. So you see here, I am defining one variable. What is that? Debug. If define debug, then we can write debug mode is on. And if so, it is checked. If defined debug is defined no, using the defined directives. That's why it is true only. That's why if it is true means here what it displayed, debug mode is on. It is displayed. So once again I'll tell you, very simple. It is value is defined or not. Value is defined or not. What is the value here? In this value is debug. Valuable or value, that is debug. It is defined. So it is defined is true only. That's why debug mode is on. So this is second type of error directives. Third one is in-def directive. In-def. What do you mean by if and defined? That means if not defined. N means not. Def means already we know very well. Def means we know very well. Def means what here? Not defined. If not defined, it executes the code only if the macro is not defined. Uh, What I can say, opposite of if defined. If defined is, it is defined means executed. If undefined means if it is not defined, then it is executed. So quite opposite. If defined, if undefined. If defined, if not defined. Both are quite opposite. This is called if and defined directives. So how we can write syntax? In syntax, if and defined, macronym, code, and if. This is the syntax. Then we can go for the example. What is the example here? Here, I should include std.h. We are define test. If an defined test, print test is not defined, and if return 0. So here test is defined in this program. No, test is not defined. We are not use the defined directive. Test is there here, not there here test. That's why it is not defined. That's why output is displayed. Test is not defined. It is displayed. Here this is the third one. So like this we can learn one by one. So many here are there. Here what are the first three I had explained in detail. Here fourth one I'm going to explain. Fourth one I'm going to explain briefly. See here hash else. What do you mean by hash else? Here compiles alternative code when the condition is false. Here compiles, it is compiling the alternative code. It is condition is false. Condition is true means here not compiled. Condition is false means it is code is here compiled. That is hash else. Next one is here hash else if. Hash else if. What do you mean by else if means check another condition if the previous one is false. Check the another condition if previous condition is false. That is the meaning of else if. So you can take else if marks is greater than 60. So marks is greater than 60 or not, it will be checked. So last one we know very well. What is that not to last one? And if if and if def and if. Here like this we are use this one. And if means ends the conditional compilation block. We are ending the compilation block. That is end if. So these all are these six categories all are called as a here conditional compilation directives. So very easy, no? Once again, I'll tell you here. I'll conclude this here. Conditional compilation directives. Conditional compilation directives. How many are there here? 6 are there. One is called as a if, another one is called as if def, and another one is called as if and def, and fourth one else, and fifth one is else if, and sixth one, last one, and if. See here, in the second part of this, what we are learned, mainly three things we are learned. What are the three things here? Passing values. Yeah, passing of values. How many here? Two or three? Two types we are passing. Call by value, call by reference. Second one we are learned about here. What is the second one? And learn about here recursive functions. Second one, recursive functions we are learned. And thirdly, we are learned about here preprocessor directives. See here, preprocessor directive. What do you mean by preprocessor directives we are learned? So first one is, what is the first one? Here what we learned first one? Here parameter passing. Second one, recursive functions. And third one is preprocessor directives. See here, any doubts are there, any clarifications are there, suggestions are there, please mention your comment. Okay, I'll give you a reply. Thank you. Thank you so much.